Hey guys, this is Daniel with PwnCNC. We're here to hook up our spindle kit with motor up to my Mega V. We basically need, obviously, the Mega V, which I've got actually sitting over on the table. I'm running out of room to record in this garage, so I've just got the controller over here, which is sufficient for our needs to get it all wired up and hooked up to the VFD and to demonstrate how to run it. I have got the controller, or the VFD, the spindle motor, the controller, the latest manual for my kit, the PWM cable for the Mega V, as well as a control software. In this case, I've got CNCJS running on a Raspberry Pi. So yeah, let's dig into it. Okay, here we are with a close-up of the VFD. The first thing, or the first step, according to our manual here on page 19, is to open it up. Obviously, I've got it unplugged, so there's no power going to it. We don't want, this exposes a couple of live screws here. We don't want to be touching that or getting into the inside of the VFD if it is plugged in. So I have it unplugged here, and I've got the PWM cable, and specifically I've got the VFD side of it, which has a red and a black wire. We're going to pass those through the little opening here at the bottom of the VFD. And what we're interested in, where we're going to be plugging these into, is on this middle terminal block. The second pin from the left is our VF1, which is the PWM line. And then the fourth from the left is our ground line. So that's where we're going to be putting the black. The PWM or VF1 is going to be where the red line goes. So we're going to hold both of those in there in place, and then I'm just going to screw them down. And we're all set. That is all that's required for the inside of the VFD. Now run this PWM line over to your CNC controller, and let's jump over and take a closer look at that. Okay, this is going to be a very tight quarters in order to get this done, so I'm going to try to film it and try to zoom in for you, but it's not going to be very good. So I've pulled the cover off from the controller. Obviously I've got it unplugged so that I don't run into any power issues inside of here. What we're after is this little board right here up towards the front. And let me see if I can maneuver myself in there so I can access it. Okay, now I've already placed my wires. As you can see in here, we've got the black wire going right into this port here, this front screw, this terminal here. The third one from the left, from the right, if you're facing the front of the controller, which is over here, is going to be the PWM signal. And right on the opposite side, headed towards the back of the controller, is your another ground pin, which we can go ahead and connect into for our drain line. There you go. You can either run that this PWM line. I've just got it sitting right here since it's for demonstration and that sort of thing. But you can run it either through the side of your enclosure, or you can run it through the back. There's an extra port here if you don't have the fourth axis, like I don't have the fourth axis here, or you can just run it through another one of the, there's a couple open ports here that you can pop this line through in order to get up here to the controller. But now that we've got the VFD wired up, we have got the controller wired up, we are ready to jump over to the VFD programming. So let's zoom in on that. Here we are with a close-up of the VFD. I have extended it with a Cat5 cable so that we can pull it up closer to the camera and you can see it. I'm working out of page number 21 on the manual, specifically the configure VFD settings for PWM control. So in order to switch this over to run, instead of using this dial indicator here, this dial for controlling the frequency, we're going to switch to using the PWM cable. And to do that, we're going to go to Mode, change this to a number 4. So we're going to go P0.0.04, hit Enter, And instead of the default value of 2, which is this turn dial here, we're actually going to change it to a 3, which says take the frequency from the PWM line. We're going to hit enter. Now, because we want this to spin up to speed as fast as possible before it makes contact with the stock, we need to increase the acceleration time and decrease the acceleration time. We need to change a couple more settings to speed it up and to slow it down faster. So we're going to change this to a P0.0.11. That's the acceleration time. By default, that's 20 seconds, but we want to switch that down to about 4. This will depend on your bits and that sort of thing. So if you're used to using really large bits or something like that, you may want to change that to something like a 6 or an 8. But for most of our 1/4-inch bits that are used for our hobby level machines, 4 is plenty enough time to give the motor enough to accelerate that bit up to full RPMs. So 0004.0, hit enter. The next value is deceleration time, which happens to be P0.0.12. So we're just going to hit enter and change this to a 4 as well. There we go. The next setting that we need to configure is our voltage level. This controller is exceedingly smart, and we can either have it set to accept a PWM signal of 0 to 10 volts or 0 to 5 volts. On our Mega V, on our controller here, it is a 0 to 5 volt signal. So we need to tell the VFD that whenever it receives 5 volts over the PWM line, that the motor should be running at the full speed of 24,000 RPMs. So we're going to switch it back over to our mode here with our P signals. We need to change it to a 2.0.15. And of course, by default, it's 0 to 10, which shows the maximum value here of 10 volts. We need to change that to a 5. Yeah. Now, a helpful setting, which might be useful for you if depending on when you purchased your kit, if you've got this purchased your kit from me, your setting this setting may not be configured properly. So what I'd recommend is let's go ahead and set it now, and let's switch it over to a 5.0.16. Now, if you spin this dial and you notice that it shows, if you set it to 6,000 RPMs and it shows 600.0, this setting needs to be 0. So this P5.0.16, change that to a 0, and that decimal point will go away and it'll properly show the correct RPMs on your screen. Now we just hit mode, and the VFD is now programmed. Now we need to jump over to our controller and tell the controller how fast the motor can go, how slow it can go, and make sure its laser mode is turned off. And then we'll run a couple test commands and then we're all done. All right, here we are with the close-up. Let me get this plugged in here. It may get a little loud. And I'm going to plug in our USB port. And that will fully bring the controller online. Obviously there's nothing to talk to, so no signals will come through, but we can interact with the controller, configure it, and even send commands over to our VFD, all from within our CAM software. And the CAM software I prefer to use is CNCJS. It runs on a Raspberry Pi. In this case, I've got it, the Pi installed into a little touchscreen 10-inch monitor with a high resolution, so everything's kind of small. So I'm going to walk you through, or talk you through, the commands that are basically outlined on page 22 of our manual. The first thing I'm going to do is connect to my CNC. There it goes. So connects up. I'm going to expand the terminal window. And by default, my system is set up to automatically run the $$ command. And that will spit out all of the Gerbil configurations that are configured on this CNC machine. Now, of course, in this controller, we've got the Gerbil commands are basically how fast it should go for the acceleration of the motors, what size it is, the Y, X, and Z capacity. It also has a couple of commands that we're interested in, and that is $30, 31, and 32. So for $30, if you don't have an index automatically output, go ahead and put $, enter, and that'll output your configuration settings. We're going to change $30 equals 24,000. We're basically telling 24, yeah, 3 zeros. It's really small on this screen here. But 24,000 is basically the maximum RPMs of the controller, or I'm sorry, of the motor. And that's listed here on page 22 again. Next we're going to do 31. So $31 equals 0. That's the minimum speed of the RPMs of the spindle. And then lastly, we're going to do $32 equals 0. 0, in this case, $32 is it's laser mode enabled, and it's a Boolean. So 0 is a false, which means no, it's not enabled, and a 1 is a true, yes, it is enabled. In our case, since we're configuring a spindle, it will be a 0. So 0, hit enter, and we can hit $, again, just to confirm our settings. Read in there, we can see that, $30 is 24,000, $31 is 0, 32 is 0. Now, we're ready for the fun part. Since everything is hooked up and you can see the VFD's controller here, it is flashing, which means it is not active. So I can send it a signal. It will display the hertz that it would send to the motor if it wasn't in a stopped state. Stopped means it's flashing. If we hit run, we'll actually see those RPMs manifest right there in the motor itself. But for right now, we're just going to test it with the motor turned off. So in the stop state, so flashing, and we're going to hit, I completely forgot. The commands we're covering are right here on page 24 of the manual, automatic control testing. So if we type in M3, which means tell the spindle to go forward, space, now we're going to put S for the speed, and then the number of RPMs. We'll put M3 space S6000. Hit enter. And what that's going to do is it's going to send the appropriate amount of voltage over the PWM line to tell the spindle to run at 1/4 of its full speed. So 6,000 being 1/4 of 2400. 100 hertz, that's the hertz setting here, is 1/4 of the 400 hertz maximum on the motor. So the motor seeing 100 hertz, it knows to run at 6,000 RPMs. If we set it to 12,000, so M3 S12,000, we can see that the hertz changes to 200, which is half of the maximum speed. And just like that, we can set M3 S24,000, enter, and it'll go to the maximum of roughly within a few degrees hertz of 400, which is the maximum. Now we can hit M5, which tells the motor to completely stop, and then it'll go down to 0 RPMs. So when you're running a job, what you're going to do is after your bit is changed and it's configured, it's ready to go, you're ready to start your job, you hit the run button, and that tells the VFD that, hey, when I receive a signal over PWM, I will actually run the motor, and you'll hear it spin up here in just a second. So if we put M3 S6000, enter, we can see that the motor has started spinning. You can actually hear it. And it's running very close to 6,000 RPMs. If we change that to M3 S12,000, we can see that it increases to 12,000 RPMs. And you can hear the motor over here. Now, this is a water-cooled motor, and I don't have coolant going through it, so I'm going to go ahead and turn it off now with the M5. And the RPMs drops down to 0. So there we go. We're all set. Okay, so hopefully you found that informative. You were able to accomplish the same thing I was, which was to install your PWM cable from the VFD over to your controller, to your Mega V, and then continue on with configuring it and testing. If you have any questions or comments, leave them down below. You can also reach out to support@PwnCNC.com. That is monitored regularly by several people so that we can get to your questions as fast as possible. And yeah, this is Daniel with PwnCNC. And remember, don't just own your CNC, dominate it.